Hey everyone, how you doing? Ron here with Innovative Digital Group. So this next question came from Mark. So Mark said, how do you do a wireless site survey for outdoors? Or how do you do an outdoor RF site survey? RF outdoor site surveys are challenging as well because one, you might not have the antenna. If you don't have the antennas, you need to call the manufacturer. Let's say you're a channel partner for Cisco. You're going to need to rent those out or get samples, or you're going to have to buy your own antennas. Hopefully you have an access point with an external RPC, and you can attach and set your levels to 50%, attach the RPC TNC connector to your access point. You're going to have a directional and some kind of Yagi dish on each side. So not on each side, but for example, this is a sample report here. Let's just merge this data, merge the path. So here's an outdoor wireless site survey, and I'm going to be talking about bridge connections. So a bridge to bridge wireless outdoor site survey, because this is on another level. Like if you're doing outdoor site surveys, you need a lot of equipment, you need a lot of locations. It's more complex because outdoor power, you're working with a lot of contractors, etc. It's usually large companies or municipalities that are doing something that's outdoor, because the outdoor AP is usually connected to a customer commercial site that bridges off of a building that they own, right? Because this is all city based, right? Because this is a city owned by the city. Maybe light poles, right? So what I'm going to be talking about is more point-to-point connections as an outdoor wireless site survey or as a yard site survey. So I've done many yards, parking lots, implementations, and it's always owned by the customer, the building, obviously. And then we're doing a yard installation for tractors, farms, etc. So, and then also bridge to bridge solutions. So basically bridging one site that has internet access from the main site to a building site that has no internet and it costs too much to get it in there. So let's start off with that one, a bridge to bridge. What are you going to need? On one side, if it's line of sight, that is less than a kilometer, and it's line of sight, you can see the exact AP that you're going to connect to. There's nothing obstructing, nothing in the way, and the noise and the air is clean. Okay, so what you're going to do, let's say this is building 1, this is building 2. You have a clear line of sight, it's straight. You're going to take your laptop in your car, roll down the windows. Let's say you have to drive 1 kilometer. You're going to monitor. You're going to do an active site survey. So turn on your laptop, doing active. See how many access points you're running into. Okay, is it too congested, etc.? What channels are free? What is the bandwidth that is being utilized across these channels? Then you can pick the channel that you want to operate on. So that's the active part. On the passive side, you just want to see that, okay, on the passive side, am I getting clear line of sight? So you're going to position your directional antenna here. You're going to have a different adapter with another directional antenna pointing. So you're going to have a different type of antenna with a directional port facing this. Then you want to see, okay, what is your SNR levels and your noise and your ratio and your basic signal? If it's clear and it's fine, perfect, good. Then same thing, go back in your car, run a spectrum analysis, and just see what you capture along the way. Just try and drive slow if you can. Maybe you want to walk that kilometer and just see if there's any interference that you're getting, right? Because this will tell you, one, okay, you can tell the customer, I see a lot of potential interference. It could work, could not, but that's the main thing. And that's why you want to do 3, the same thing. You want to do active site survey because you want to make sure that signal is 100%. 2, you want to do the passive so you know what potential interference here. 3 is you want to do the spectrum analysis, and that'll tell your customer yes, no, because if there's too much noise in the air, right away you could say, okay, you can do it, but it's not going to work 100% because I'm already seeing a lot of disconnects. So you might want to have a better option of just getting internet in this location. So that's how you do a wireless RF outdoor survey for a bridge to bridge. Now let's say this is a building and we want to cover parts of this street. Let's say it's a backyard, a yard, and a parking lot. We did one for car manufacturer that had to scan cars in the parking lot. So they had light poles. We put a light pole here. There was an existing light pole, so we needed a bridge connection, as long as that AP had power, it would use the Ethernet side and transmit the data from this access point to here. And the only thing we needed was power to this AP. It had to be in a NEMA box, external antennas, and then it would provide coverage here. So with today's technology, it's a lot easier. You work with the Meraki access point that has an outdoor. You could just provide power over Ethernet, but have a bridge connection here that is going to use the data portion. So the layer 2, layer 3, okay? It's going to get its Ethernet, its network information from here. All you have to do is supply it power through some kind of PoE adapter or some conduit with power and a NEMA box. So it's really up to you. The cost, it's a little more costly when you start using NEMA boxes, whereas you could buy an outdoor Meraki MR outdoor series antenna, make sure it's powered, it has the specs for lasting condensation, the heat, the cold, plop it in from here, make sure that it gets its network and it has the same properties in terms of, you know, the active site survey has a clear line of sight, you can get to it, it's going to feed off of here, great. Do a passive, make sure everything, potential sources of interference are known from your passive and your wireless interference, so your spectrum analysis, and that's it. So you've got, well, that's not it, sorry, this is your bridge from here to here, but let's say you didn't need this NEMA bridge, this access point in here. What I like to use is, you know what, so I've done this a couple of ways. One, I've used Omni antennas because it works, even though it gives you a radius coverage of like a donut. I've used omnidirectional antennas because it just covers so much, because it's all clear, it's a parking lot, nothing obstructs it except for a car, and it's so high up, you're fine. So you can have 1, 2, like let's say you're covering just this area, like 2 is fine, 1 as a backup, and that's it. You do your test, you do your active, your passive, and the spectrum analysis. Another way of doing this, let's say it's a long yard and you need more coverage. I've used directional antennas with a 30-degree beam. So 30 degree, like a V shape. So you're coming here. This gets more challenging because, one, you're not going to get as much coverage here from the outsides, but it's going to spread out in a V like this. So as you put in your first antenna, when you're doing your site survey, you're just testing. Okay, you want to test the challenging parts, like here. What if they're scanning here? What is my coverage here? Because I know that the beam is 30 degrees. What is my coverage around here? And how far can this directional antenna get over here? Right? Because an omnidirectional might not work, but a directional might give you a kilometer, but you don't get much coverage here. The higher the gain, you're not going to get as much. You're going to get an umbrella effect. You're not going to get as much coverage here, right? If the higher the gain, if you start using 9 to 12 dB, you're not going to get that much here. Sure, you'll pump out a lot of RF and coverage here, but not around these areas. So the main thing is just know the beam pattern. Look at the specs of the antenna. Look at the beam pattern. Estimate your angle. Start looking at this area. Okay, well, if I put it here, am I going to get coverage here? And then you do your walkthrough, maybe in your car, maybe on a bike, etc. And then if you don't get enough coverage here, then you're going to have to just put more directional, right? And just realize and tell the customer that even with an omnidirectional antenna, we're not getting enough coverage out here. So we have to use directional antennas to extend here. Or the second option is if you have light poles, or if you install a post, is that more cost effective to put a post with power? Then you can use a bridge like the Meraki MR Outdoor Series. Connect here, it uses the Ethernet from the inside of your building to transmit, carry over, and then push the data out here. That is probably the best way of doing it. But if they don't, then your option is directional antenna that can reach out far, but you're going to be using more directionals here. So hopefully your first bet, safe bet, is hopefully you can use an omnidirectional antenna, not just a directional. Okay, hopefully you can use an omnidirectional and it reaches this far. So when you're running an outdoor survey, you probably want to just stick to 2.4. Hopefully 2.4 isn't crowded and this is a lonely area. But if it's too crowded, 2.4 is just not recommended. If you use 5 gig, you're going to get a lot of bandwidth, but shorter distance-wise on your coverage. So that's how you perform a wireless outdoor RF survey. If you have any questions, let me know in the comments. Thanks.